Okay, we are dealing here for 7, 9, and 11 with the 45, 45, 90 right triangle. This is a special right triangle. It's got special relations in its sides. And in fact, down here at the bottom, I have inserted a little, like our little template for how to figure it out. If each leg is measuring x, then the hypotenuse is measuring x square root of 2. And we're going to use that for the first one straight away because it says that the leg is 8. And if you imagine down on the bottom here, if x was 8, then what would the hypotenuse be? It would be 8 root 2. So we can say y is equal to 8 square root of 2. Well, what's x? X, as you can see for the 45, 45, 90, remember this is an isosceles triangle. These two angles are the same, so their opposite sides here and here, the legs, are going to be the same. So if one leg is 8, then the other leg is 8 as well, and x equals 8. So we have 8, 8, 8 root 2. Just like on the bottom, you have x, x, x root 2. We just replace the x with the number 8, 8, 8, 8 root 2. Yep, just like that. All right, let's do these other ones. Number 9, we see that the leg is 60. They're not asking us for this other leg. We should also know at this point that that's also 60. But what is y? Well, check it out down here on the bottom. If you know the length of a leg, x, then you just multiply that by the square root of 2 for the hypotenuse. So for number 9, we've got a hypotenuse length, y, equaling 60 square root of 2. And you should know that the square root of 2 is just a number that actually, if you calculated it, the square root of 2 is approximately equal to 1.414, approximately. So what you're really saying is the length of that hypotenuse is 60 times approximately 1.414. Okay, so you can actually calculate that as a length instead of writing it as a radical, but what you want to do is answer it the way that the problem is asking. And if you look up top, it says if your answer is not an integer, and it's not, 60 root 2 is not an integer, express it in simplest radical form. They don't want you to round it off. They don't want you to multiply it by what root 2 is equal to. They want you to just write it as 60 root 2. That's its perfect exact answer. Radicals are irrational numbers, and assuming they don't work out to be integers, like the square root of 25, square root of 25 is not irrational because that's equal to exactly 5, right? But anything that doesn't work out as a perfect root is going to be an irrational number, meaning there's no way to write it perfectly with decimal numbers or fractions. So what you have to do is leave it in the radical form, okay? So that's the second one. Let's do the third one here. We now know that, well, we know what the hypotenuse is. The hypotenuse is 10, okay? And we need to actually now find the leg. So what you want to do is say if the leg is x, then the hypotenuse 10 is equal to the leg x times the square root of 2. And what you will then do here is you say, oh, I'm going to solve both sides for x. And so I'm going to show you one way to do it, and I'm going to show you what the video tutorial that I've linked at the top of the lesson page. The guy in there has a clever way of explaining how to kind of simplify this for you, and I'll show you that in a second. So anyway, first thing is you say, okay, we know the hypotenuse needs to be set equal to x root 2 in order to find what x is. So we do that, 10 is equal to x root 2, and then we divide both sides by the square root of 2 in order to cancel out that root and just be left with x, okay? And we now have 10 over the square root of 2, but we want to rationalize the denominator. So I'm going to do that over here on the left. We want to rationalize the denominator. So if we have 10 times the square root of 2, what we want to do is multiply it by square root of 2 over square root of 2. And the square root of 2 times the square root of 2 on the bottom is equal to 2. And on top, we get 10 times root 2, or 10 root 2. Okay? Now, you can simplify this further by saying you can divide 10 times this divided by 2 is 5 times that, right? You still get the root 2 on top, but now you have 10 over 2 is equal to 5, and so you can write that as 5 root 2. Okay? So we can then say x is equal to 5 square root of 2. Now, let's take a look at something interesting then that always happens. Let me get rid of this. Something interesting that always happens. If you have a whole number hypotenuse like we did for number 11, then, and let me just write this idea here in blue. If you had, let's say, 36, okay? If you solved it out and you wanted to know what x was, this is a 45, 45, 90. I can say that those are equal. That makes it 45, 45, 90. Then you're always going to get the length of the hypotenuse divided by 2, so 18, and then multiplied by the square root of 2. Why is that? Because if you imagine that x, that side length is, in this case, let's say 18 square root of 2, and you're always taking that amount, whatever x is, and you're multiplying it by root 2 in order to get the hypotenuse, then the root 2 and the root 2 multiply together to be 2. And then what's 18 times 2? 18 times 2 is 36, which gets you back to this number. Okay? So since you're always going to have to have a root 2 in the original x value in order to multiply with root 2 and have that disappear, then you're going to end up, when you multiply that, getting times 2. So what number do you multiply times 2 to get this? 18. So the 18's got to be sitting out front, plus a root 2 that will multiply by the root 2 you always multiply the leg by to get the hypotenuse. So 18 root 2 times root 2 is the same as 18 times 2, or 36. So quick trick for all of those is that if you see that in a 45, 45, 90, that you've got a hypotenuse length that's a whole number, then divide it by 2, and then multiply that by the square root of 2. And this is what we did here. We took 10, which was here up top. Oops. 10, which was here up top. We divided it by 2 to get 5. And then we multiplied that number by root 2. And as you can see, that's exactly what we did get